Hello. Welcome to DevOps in a serverless world. My name is Alexis, and I've just deployed a new version of my demo. I hope this was not a bad idea. We'll see. So we'll get to talk about serverless and how it relates to ops. I'll talk about some of the best practices that we've developed at Google, and I'll show you some tools that we have working and that you can use as well. The rest of this presentation will focus mostly on public serverless, but hopefully some of the of what I cover applies also to on-premises solutions, anything that's based on Knative and the emerging technologies that will, for example, on top of Kubernetes, provide a serverless environment. So serverless, there's sometimes confusion, certainly a few jokes about the term serverless. In the broader sense of the computing paradigm, that involves not using the abstraction of a server. But it's kind of weird to define a name by what it's not. So how about we use something else? Because of course they are servers. How about we call it no-ops? The term tries to capture the fact that developers using serverless can focus on code rather than the infrastructure. Well, it turns out it's not really better. Well, first of all, it's also defining something by what it's not. And if you define ops as operations and the practices that keep your tech and your business going, no ops is probably not a good idea either. Implying that operations may go away is clearly, I think, a misunderstanding of ops in general and DevOps in particular. So sorry, I don't have a better name than serverless, and certainly no ops is not a good one. If you came for a better name than serverless, then sorry, I don't have one for you. So let's go and talk about some of the challenges when it comes to monitoring serverless. So by definition, you know, the servers are not accessible. You don't have this notion. So there are no agents. There's no SSH. There's no way for you to just SSH into the machine. That is just not something that we will let you do. And that holds true for all the cloud providers. The other challenge is that you're in a auto-scaling mode. You cannot rely on the fact that 2 requests will go to the same instance. You might be hitting another instance because we're rapidly scaling. You might be hitting another one for different reasons. But the auto-scaling part makes the whole thing have a lot of parts that are moving parts and makes it somewhat harder to monitor unless you have the right metrics and the right observability in place. And of course, if you've heard of serverless, you probably have heard of cold starts. You know, this time that it takes for a new instance to start because it needs to provision the environment and start your app or new copy of your app. So you probably don't want to add additional libraries for monitoring or for observability to your app because that would only increase the cold starts. So that's a challenge as well. One of the promises of microservices is that you have the ability to operate each service independently. They have different life cycles, they have different versions, they have different scaling policies, they have potentially lots of different ways that you manage them. And auto-scaling applied to the granularity that microservices offer is actually nice because that means you can scale from 0 to n, those individual microservices, and get better economics in the cloud environment at the end of the day. But this obviously leads to way more pieces to monitor and operate. If you want to trace calls between microservices, that also becomes critical. And that's a problem you didn't have when you had a monolith. And of course, you know, you can, depending on your dependency graph, a service failing might cause cascading failures. So you want to be able to track that as well. In the case of functions as a service, which to us is a subset of serverless, but a very interesting one, it's often the case that different kinds of events can trigger the execution of a function. It could be an HTTP call, which is kind of a special case of other types of events. It could be something uploaded to a bucket. It could be a message posted to a message queue. It could be an event happening anywhere in your system. So wherever you used to have something like a good old HTTP proxy to filter stuff, well, that no longer applies. It's a bit more complicated than that, given the new types of events that you have that can trigger the execution of a microservice or a function in that case. So let me explain the demo before I get into more of the best practices that we've developed at Google. It's called Pick a Daily. It's available for you to use. If anybody was here in the room yesterday when I presented the overview of serverless at Google, this is the same demo. It's really a photo sharing app. It's fairly basic. You will upload a photo. It's a progressive web app, so you can use it from your phone, no matter what kind of phone you use, and you can navigate to it from a laptop as well and have different experiences. The moment you post a photo, it will be analyzed by our Vision API, and we will add to it a number of attributes. And these attributes are the things that the Vision API sees on the picture. In this case, this is fruit, strawberry, and so forth. Now, because we have all those tags, we're able to compute a most popular tag page, which I'll get back to. And eventually, you can click on one of those links, and you can see all the photos that have this attribute. So you can look at all the food photos, for example. Now, this being a user-generated content, as we say, I don't exactly trust all of you guys and gals. So I have an admin page where I can filter stuff out. If stuff that is being uploaded is being flagged as problematic in different ways, it's something that's not safe to show, I get to review that. It's a fun job. And publish or delete. So anytime you have something that's generated by your users, you owe it to yourself to use something that's automated, probably like this, this solution that I have here. So the architecture uses different types of products that certainly we have at Google, but think of it as different microservices implemented in either App Engine in our case or Cloud Functions. We have a front end, obviously, that's serving the pages and the UI, that is storing in Cloud Store the pictures. This triggers an event as soon as there's a new file there that will trigger a function which will itself call the Vision API. The answer that we get back is being parsed and then written into data store, which is also something we read into when we present you with the list of tags and how frequently they're being used. This is a fully serverless architecture, no server harm in this demo. And we also have the ability here to trigger on a regular basis a task that's a bit more expensive to compute, which is that page that computes the most popular ones. That is being triggered by posting a message to PubSub and consuming it from a function and actually going into the data store and updating the data. And as I mentioned, I have an admin app, which happens to be written in a different language than everything else. There's Java, Node, and Go. These are the three languages used by this app. So before I get into this, first of all, I encourage you to use it so we actually have some data. Otherwise, I'll generate something. Yeah, people are using it because I'm seeing alerts here. So thank you. Let's go to and talk about some of the best practices that Google has developed. We've, as Google, been running massive service, like massive scale services. And when we talk about DevOps, internally at Google, we map this to something called SRE, Site Reliability Engineering. SRE at Google is a title. It's very highly respected. And these people are software engineers tasked with what used to be called operations. That's how we look at it. DevOps appeared, I think, about 10 years ago. SRE has been around for actually a bit longer than that at Google, something like 15 years. So I encourage you to actually look up on Wikipedia or elsewhere, and you'll see that SRE and DevOps are very similar. SRE certainly satisfies the various pillars that DevOps defines. In fact, you could probably state this, which is class SRE implements DevOps. That would be a fair statement. That's how we look at it, certainly, at Google. There are other valid implementations of DevOps, and just Google uses SRE. You say DevOps, we think SRE. It's interesting because the industry has almost standardized on SRE as a term, like Microsoft, Apple, Twitter, Facebook, Amazon, IBM, Oracle, VMware, they're all hiring SREs. So we run these things, like we probably recognize a few pictures. They all have in common that they serve more than 1 billion users, monthly active users. And that's managed by a team of 2,000 SREs at Google. 2,000, maybe a bit more now, but we're in the 2,000 ballpark. If you do the math, given how many users there are, it's pretty incredible. And that team of SREs has to manage two things, make sure things are reliable, but also provide some agility to developers so that you're not stuck with one version not being able to change anything because you might be taking the risk of breaking something. So how do you balance the two? Reliability on one side and agility on the other. Now, of course, not everybody's serving billions of users, but I think the model here applies to a lot of the things that you guys are doing as well. And probably you don't want to have a lot of people running around. You cannot afford to have a lot of people looking after your application. So you need to find a better way to scale. And the first thing for that is the culture. Folks at Google have written a book that's called the SRE book. It's actually on sale here if you're interested at the conference. And the goal for SREs is really, yes, they carry a pager, but the goal is not to run around fixing things all the time, pulled into 20 directions and try to put out fires. That's not what they do. They try to automate themselves out of the job. That's really what they try to do. They can actually refuse to carry the pager because the app you ask them to look after is not well written in terms of observability, management. They don't want to do it because they know it's not being written well. SREs are usually involved very early on in the development of the app so that they can make sure they have the data they need to operate this at scale. The second thing is that you need to have an infrastructure. If you have, one SRE for 10 engineers, that one SRE cannot go to the 10 engineers and say, you need to put this trace in, and you need to publish this data, and I need to see that. That would just not scale again. So instead, Google, everything is quite opinionated, and we baked into the infrastructure the fact that every service has a name, is discoverable, has quota, permissions, and base telemetry. That's really an important thing. And so your cloud provider, typically us as Google Cloud, we provide you with monitoring and management tools that offer these data presented to you. In our case, that's called Stackdriver. And we've open sourced a number of the technologies that we use, such as gRPC for inter-services communication and OpenCensus for logging and tracing. The third element is a platform, a place where you can actually capture and store all of this potentially massive amount of data. A time series database is probably what you're looking for. That's what we use. It allows for storing, querying, and running all sorts of analytics. And finally, there's the tip of the iceberg, the thing that you get to use, the tools that will help you look at logs, traces, maybe debug tools for production, profilers, that kind of thing. So I'll try to show some of these in a second. But going back to the SRE culture, rather than playing whack-a-mole, trying to put out fires all the time, SREs look at what impacts customers really directly, or users in general. So let's take an example. A CPU goes to 80%. Is that something that's worth waking up an SRE in the middle of the night? It could affect the customer, maybe, but we've done the obvious thing of automating the problem by implementing auto-scaling. So eventually, we'll spin up a new instance, and the other one will go back to something lower than that. And the end user will not see the problem. So there's no point in paging anyone at that point. Instead, SLI, or service level indicator, are indicators that affect your customers. So that's really how you should define them. There are two obvious ones. One is availability. How many requests do not come back with a 200 type of response, 400, 500, that type of thing. And the latency. What percentage of my requests come back with responses that are less than, say, 300 milliseconds? Once you've identified those, you can make a promise. So impacting the business is usually what you should be looking at. And once you've identified those, you can try to make a promise or a service level objective. So typically, this is something where you say, for example, 99.9% of my responses will be 200 responses. HTTP 200 responses. Or 99% of my calls will come back in less than 300 milliseconds. And you cannot promise 100. I didn't say 100% of my requests will come back in less than 300 milliseconds. In fact, at Google, SLOs are never set at 100%. We don't even try to achieve 100%. It might seem counterintuitive, but it's really an important part of the SRE culture. Because that would mean we would never change anything. You cannot, make the services better. In fact, what we do is we define what we call an error budget. 100% is the ideal goal, which we do not try to reach. And then if you take out the SLO, you get the error budget. And that's something, as any budget, that you manage. If you're not using your budget, you're not trying stuff enough. And you're probably having your customers be too accustomed to some really high SLIs, which you don't want that, because the moment you start testing stuff or deploying more features, they will start complaining that they don't have the service that they used to have. On the other hand, if you start having running out of budget, especially if you do that rapidly, that means you have a problem. You have some sort of, you need to stop shipping features and fix the reliability of your system. Maybe that's technical debt. I don't know how you define that, but it's a clear indicator that you have a problem. And finally, there's SLA, but SLA is really a commitment, a financial, contractual commitment that you make to your customer. And it's just a business version of an SLO. Typically, SREs talk about SLOs. SLAs is the business people's job to talk about. You're probably building your microservices several times a day. And hopefully they all have a version, and maybe it's a reproducible build. And modern serverless runtimes allow you to manage multiple versions of your services, sometimes at the same time. So they're all active at the same time, and you can do things such as traffic routing, where you do A/B testing, you do canary releases, and all of that is actually really good practices, but you need to have the infrastructure in place so that you can do that. And your management and monitoring tools should be aware of that. What version of the service am I hitting? What version of my service is actually producing those errors? Maybe it's just a specific one, and I need to have tools to help me pinpoint the one that is producing the problems. And as I mentioned, canary and blue-green releases are something else that an infrastructure should be able to provide to you with, say, easy rollback. Or maybe a way to implement A/B testing. You deploy a new module, and you offer your customers two choices, like, do you want free shipping or do you want 10% off? And then maybe it's a 50% split, and you see how people react. All of these things should be fairly easy to deploy and should be easy to manage and to analyze. So tools are really important at this point. I'll be showing you some of the tools with the demo. And in the case of Google, that's called Stackdriver. That's the one-stop shop for all the tools that we have for monitoring, tracing, debugging, and so forth. And it's based really on all the findings we've developed and those best practices. Lots of things to look at. So with the time that I have left, let me try to jump into the demo. And so do this, and here we go. So here's the app. Let me refresh it, see what has been posted there. Let me get rid of that. And let me do a full screen. Yes, typically these are fairly recent photos taken, I believe, in this room. Not the prettiest pictures, but you know, they're there. Quite a few similar ones. That must have been some testing that I've been doing. So let's look at the, actually, sorry, before I get to the admin, you can see that every picture here is posted with a different background. That background is the color that's being returned by the API and is what is considered the dominant color for the picture. And of course, you can also see here that we have those tags that I mentioned. Hopefully, these are fairly accurate. And we do have that tags page, which if I click there, will give you a link of all the tags that we've recently seen with frequencies. If I click on one of them, I'll say material. Oops. That is probably why I was afraid to push a new version just before I started to talk. So let's see, what can we do here? Well, first of all, I can show you the admin thing where I can delete a few pictures if I wanted to, like my test, for example. These are things I should be deleting. But let's see if anything was here flagged as inappropriate. Turns out a few things were flagged as inappropriate. And these are not all pictures you guys posted today, but I can decide to publish those or delete them. So this is considered violent. You can see why, but clearly it's a false positive. So let's get into the dashboard and the various things we have to show here. So this is the dashboard of my app that has app engine parts, different versions deployed, all active at the same time, different buckets in which I place my images, and functions, the two functions, one which talks to the Vision API and the other one that computes the tags and their frequencies. And I have a bunch of graphs, API latency calls, but actually let me go into the log part. The log part, jump to now and make it dynamic and bigger so you guys can actually see something. These are aggregated logs. Like this is where I see all the logs for my entire application. And this is where I can do things such as filter stuff out because this is noise to me. So there's a whole syntax here that you can use and you can share URLs across the team. And I want to filter this one out as well. And then you get the actual calls, which typically all look kind of the same. You know, request, the slash, and then there's a bunch of things that happen, and there's eventually post methods somewhere. Here, typically when I delete, it's a post. Maybe it should be a delete. But when I post pictures, typically this is what happens. Now, I have a different tool for analyzing traces. Let me do some auto reload here. Maybe even refresh the page just in case. Traces are, you know, how you trace a call going through different parts of your system. So it can give you heat maps, and maybe I want to look at the last 4 hours or just the last hour. And you can filter this. This is the path that's interesting, but if I look at the delete path, for example, I can see all the slash deletes, hopefully, if all goes well. Okay. I don't know what the SLO is for this one. All right, let me refresh. That's part of the error budget. See what happens there. And in the last 4 hours, I should have deleted stuff, or maybe it's not delete. Yeah, it is delete. All right, let me just reset that. Maybe I'll find a delete by clicking here. I wanted to show you, or maybe I can actually go and delete one now. Filtered, sorry, and maybe just delete a few here. There you go. So back to traces here. Auto reload. and eventually I should get a delete. And you can see at all of these events, and you can see here the timeline. This is a very simple one, so there's no waterfall here, but this is why I want to show you a delete one. Actually, if I filter on posts, this is a little bit too big. I can see that there's a tendency here for some of the posts. Typically, it looks like API pictures that take a bit longer than others. It used to not be that long. So if I look at the 12-hour history, it used to be down here, and now I have this up there. This is a bit weird. So oh, and here's a waterfall where you can see calls through the system. In this case, we also have calls to some of the debugger tools that we have. So let me actually look at this, and I can filter for API pictures, and I want to see the posts. And yeah, these are pretty high up. And if I look at all the versions, it used to be a lot lower than that. And I can zoom in here, and clearly there's a problem. So I don't know what happened around 5 p.m. That's probably when I deployed my version. So maybe we can actually do something about this. And this is a post on this URL, and this is same post, same URL. Clearly different response times. So I'm probably burning through some error budget at this point. Oh, and also, I think I received an email. Did I not? Yeah, I have this tag driver notification that says, hey, there's an error here. An error that used to happen, that you said was resolved, but clearly happens again. So what is this? Maybe that's the 500 error we saw earlier. So thankfully, this error reporting part of the tool helped me track this. It says, it's happened quite a few times actually in the last 5 days. It was seen the first time 5 days ago. It's a 500 error, looks like what I had, and it was last seen 2 minutes ago. Here's the stack trace. We removed some of the stuff that we have, the runtime. We hopefully show you only relevant code for you. And here are some of the recent samples. So that actually looks like what my error is. So I can jump into code. And the code here should make it pretty obvious that I was just faking an exception, assuming I would go through this code path. So I think it's probably a wise thing to do to go to the version of my app, and clearly the bogus version was bogus, and send all the traffic back to the previous one. I could split traffic, I could do A/B testing, this is where I would do the same, but in this case I want 100% of the traffic to go from the bogus one back to the current version. And that should take just a few moments, and hopefully when I do this and I go back to the tool, to the app, I can see anything new here, go back to tags, and if I click on one of the tags, say, I don't know, city, this time it actually works. So I really just roll back a version of my app, and I can see pictures of a city. There are a few more things that I could be showing. We have a debugger. The debugger is really nice because you can do two things. You can do snapshots. You can say at a given point, give me, obviously it's not a breakpoint, give me all the status of all the variables at this given point. When you hit that screenshot, that snapshot, it will print everything here. I actually have one open right now. And we have log points. How many times you edited code, redeployed just to add some log statements? This is something that you can do dynamically here. So you can do things such as after this line, if true, which is always, or for a given circumstance, print the value of, say, model, whatever model is in this case. And there's a syntax for doing that. And maybe I really want to see this in the log, so put warning and add. And as soon as I hit that, that will be in the logs. And it can be processed as logs that were natively thought of in the platform. So with that, let me quickly close with some of the slides here and tell you that we're working on a tool. You'll get the slides, so you'll see all the details of the tools that we have here reporting debugger. We have tools to manage actually an SLO, and that's really important. So far, you've seen me look at different response times and latency. Maybe you want to define this as a baseline, and you want to be notified when your SLO is actually not being met anymore and you're running out of error budget. That's something we're working on, should be available fairly soon. Now, the elephant in the room is cost controls. The good news is that there are solutions. The bad news is that they're usually specific to the vendor that you use. For Google Cloud, you can receive alerts, decide to disable stuff, but the problem here is you have to decide what to do when you run out of actual real budget. There's no, is shutting down the service really what you want to do? Not always the case. And who should take that decision? That's an exercise left up to you. And so the recap is no ops clearly doesn't mean, serverless clearly doesn't mean no ops. It's not a better term. Ops actually becomes really important and helps you focus on what's important, what impacts your users. And there are a number of best practices that we've defined as part of SRE. And tools require opinionated runtimes that actually publish a number of things for you and enable tools to provide the features that I've clearly just demonstrated. So with that, I have a few resources for you, the books that are on sale here, and that you can get the first one online for free, and a series of videos on SREs, which are short and sweet, and I encourage you to look at those. It's called Class SRE Implements DevOps. And with that, thank you very much. If you have questions, please come up to me. I think we ran out of time. Thank you very much.